there is a sound that defines the modern world. A sound that begins as a low whine, builds into a howl, then erupts into a wall of raw, physical thunder. It is the sound of a jet engine, and no nation on Earth has built more of them than the United States of America. This is the story of 100 American jet engines. So buckle up and let's start with General Electric 1A. Begins in secrecy and urgency, a rough but decisive breakthrough that proved America could build a working jet engine. It powered the first US jet aircraft, giving pilots that eerie, almost silent push into a new era. Next, General Electric 116/J31 added more thrust, but still fell short of real combat performance. It marked an in-between stage, more capable than before, yet not ready to truly fight. Now, the General Electric 140/J33 changed the game, delivering a massive jump in power and enabling America's first operational jet fighter. For the first time, US pilots had a jet that could match speed with purpose. Westinghouse J30 took a different direction, introducing axial flow design in a compact, forward-thinking package. It showed where the future was heading, even if it couldn't fully carry the moment. Then the Westinghouse J34 refined that idea into something reliable and combat-ready, powering early Navy jets into real success. It stood as the company's strongest contribution before the industry surged ahead. Now, Allison J35 turned jet power into scale, becoming America's first mass-produced axial flow engine. It powered early Cold War aircraft and proved jets were no longer experiments, but the new standard. Next, Pratt & Whitney J42 borrowed British brilliance and turned it into dependable naval power. It wasn't glamorous, but it kept US aviation competitive while domestic designs caught up. Then Pratt & Whitney J48 improved on that borrowed foundation, pushing higher thrust and powering the Navy's first swept-wing fighter. It showed how quickly adaptation could turn into innovation. Now the General Electric J47 became the backbone of American air power, produced in huge numbers and central to air combat in Korea. It powered both fighters and bombers, making it one of the most influential engines of its time. Pratt & Whitney J57 marked true maturity, introducing a revolutionary design that unlocked far greater performance. It powered iconic aircraft like the B-52 and U-2, proving one engine could shape decades of aviation history. General Electric J73 pushed the Sabre further, turning it into a serious ground attack platform with the unsettling capability to carry nuclear weapons. It reflected an era when speed and firepower blurred into atomic strategy. Next, Wright J65 carried British design into American service, powering early fighters while linking aviation's past to its rapidly accelerating future. It stood at a moment where pioneers of flight had just witnessed jets nearing the sound barrier. Now Pratt & Whitney J52 brought rugged reliability to naval aviation, driving aircraft through the most dangerous, low-level missions of Vietnam. It became known for enduring extreme conditions where precision and survival went hand in hand. Then, the General Electric J79 defined high-performance flight, introducing variable stators that enabled stable power all the way past Mach 2. It powered some of the most iconic aircraft of the Cold War, combining speed, power, and unmistakable presence. Pratt & Whitney J75 followed as a raw powerhouse, delivering immense thrust to aircraft flying into the most heavily defended skies. It gave pilots the ability to outrun threats and survive missions that pushed both machine and human to their limits. Now, the General Electric CJ805 adapted military power for civilian speed, turning jetliners into sleek, fast machines that prioritized performance over efficiency. It showed how close commercial aviation could come to the edge of pure speed. Next, Pratt & Whitney JT3C brought jets to the public, cutting travel times in half and shrinking the world in a way people could feel immediately. It marked the moment air travel became a shared global experience. Then, Pratt & Whitney JT4A extended that reach across oceans, giving aircraft the thrust needed for true intercontinental travel. It made non-stop global connections a practical reality for the first time. Now, Pratt & Whitney JT8D powered the explosion of mass air travel, becoming one of the most widely used engines in aviation history. It was everywhere, carrying millions of passengers as flying became routine. The JT8D's long legacy proved its impact, staying in production for decades and remaining in service long after newer designs appeared. It became a symbol of reliability at the heart of commercial aviation's growth. General Electric CF700 introduced turbofan thinking in a small, practical way, proving that adding bypass airflow could improve efficiency and reshape engine design. It powered early business jets and even helped launch overnight air cargo, quietly changing how the world moved goods. Next, General Electric TF39 delivered a true breakthrough, becoming the first high-bypass turbofan and redefining efficiency, noise, and thrust. It powered massive airlifters and set the blueprint for nearly every modern jet engine that followed. Then, General Electric CF6 carried that momentum forward, combining reliability and performance across decades of wide-body aviation. It became one of the most trusted engines in commercial flight, proving longevity matters as much as innovation. Pratt & Whitney TF30 showed the risks of pushing boundaries, performing well in some roles but struggling under the demands of high-performance fighters. It became a lesson that even advanced designs must match the aircraft they serve. Now, General Electric F101 emerged as a powerful foundation, originally built for bombers, but ultimately giving rise to an entire generation of fighter engines. Its legacy lived on far beyond its first purpose. Next, Pratt & Whitney F100 powered America's frontline fighters, delivering unmatched performance, but also early reliability challenges. Those struggles sparked competition that would reshape the entire engine industry. Then, General Electric F110 answered that challenge, offering more thrust and smoother performance while breaking a long-standing monopoly. It turned competition into progress, raising the standard for fighter engines. Now, General Electric F404 refined the formula into a highly reliable and pilot-friendly engine, avoiding past flaws and powering versatile aircraft across multiple roles. It became a benchmark for balance between power and control. General Electric F118 took performance into the shadows, powering stealth and high-altitude aircraft, where reliability and subtlety mattered more than raw speed. It operates quietly behind some of the most secretive missions ever flown. Lycoming T-53 shifted the focus from speed to survival, powering the Huey helicopter that defined an entire war and carried millions through combat zones. Its unmistakable rotor sound became a lasting symbol of both rescue and conflict. Next, General Electric T64 brought heavy lift capability to life, enabling helicopters to move massive loads and perform relentless evacuation missions under extreme pressure. It proved endurance could be just as critical as raw power. Now, Pratt & Whitney TF33 quietly became a backbone of long-range operations, extending the life and efficiency of strategic aircraft while supporting airborne surveillance across decades. It showed that reliability over time can shape entire missions. Then, Allison T-56 turned efficiency into legend, powering aircraft that served everywhere from battlefields to disaster zones. Its longevity and versatility made it one of the most trusted engines ever built. Pratt & Whitney JT8D-200 revived an older design with modern improvements, keeping it relevant in a changing commercial world. It powered workhorse airliners that airlines depended on day after day. Now, General Electric /SNEC MACFM56 became the heartbeat of global aviation, produced in massive numbers and powering the most common aircraft in the skies. It defined reliability and scale for modern air travel. Next, Pratt & Whitney JT9D7R4 pushed forward with early digital controls, marking the transition towards smarter, more automated engine management. It helped reshape how aircraft operated over long distances. Then, General Electric CF34 made regional aviation possible on a large scale, connecting smaller cities with quiet efficiency. It became an essential link in the everyday travel network. Now, Pratt & Whitney PW2000/F117 balance commercial and military roles, powering both passenger aircraft and strategic airlifters. It showed how one design could serve entirely different missions with equal effectiveness. General Electric GE90 reached the peak of sheer power, setting records and enabling ultra-long-haul travel across the globe. It stands as one of the most impressive engineering achievements in aviation history. And the Pratt & Whitney PW4000 closed the era with versatility and advanced digital control, powering a wide range of aircraft with precision and reliability. It marked the moment when computers became integral to engine performance. Allison AE3007 brought efficiency and range to regional jets, allowing smaller cities to stay connected without the cost of larger aircraft. It also powered high-speed business travel, pushing corporate aviation to the edge of the sound barrier. Next, Pratt & Whitney F119 redefined fighter performance, enabling sustained supersonic flight without afterburner and unlocking unprecedented agility. It powered aircraft that could maneuver in ways that seemed almost impossible. Now, the General Electric/Rolls-Royce F136 stands as the engine that never was, a nearly complete design cancelled before it could prove itself in service. It remains a reminder that even advanced technology can be stopped by decisions beyond engineering. Then, Pratt & Whitney F135 pushed power to new extremes, driving the most advanced multi-role fighter and enabling vertical lift in a supersonic stealth jet. It represents the peak of modern fighter engine complexity and capability. General Electric F414, built on proven design, delivering more thrust and reliability while powering a new generation of naval aircraft. It showed how refinement, not reinvention, can produce lasting success. Now, General Electric T700/GEC T7 became the backbone of military helicopters, valued as much for its ease of maintenance as for its performance. It proved that in combat, simplicity and reliability can outweigh everything else. Next, Pratt & Whitney Canada PW150 emphasized efficiency over speed, powering turboprop aircraft that excel on shorter routes. It showed that smart design choices can outperform raw performance in the right conditions. Then, General Electric GEnx introduced advanced materials and cleaner combustion, reshaping expectations for fuel efficiency and environmental impact. It helped define a new generation of long-haul aircraft. Now, Pratt & Whitney PW1000G geared turbofan changed the rules again, using a gearbox to unlock better efficiency and quieter operation. Despite early challenges, it represents one of the most important shifts in modern engine design. CFM LEAP represents the modern standard in commercial propulsion, combining efficiency and advanced materials to power today's most widely used airliners. Despite being linked to controversy through aircraft design decisions, the engine itself remains a benchmark of reliability and performance. Now, Pratt & Whitney F100PW229 refined a proven fighter engine, delivering the durability and control needed for sustained combat operations. It showed how continuous improvement can turn a once problematic design into a dependable asset. Honeywell HTF7000 opened new possibilities in business aviation, enabling long-range travel with consistent performance and reliability. It helped make private jet travel more practical and accessible. Next, Williams FJ44 brought efficiency to smaller jets, allowing individuals and small operators to access reliable jet performance. It played a key role in expanding personal and regional aviation. Now, Williams F107 operates in a completely different realm, powering precision-guided missiles with compact efficiency and long range. It showed how small engines could have outsized strategic impact. Then, General Electric T408 delivers immense lifting power, enabling the most capable heavy-lift helicopters ever built. It proves that raw strength still matters in modern military operations. Next, GE Aerospace XA100 reimagines the jet engine itself, introducing adaptive airflow that can shift between efficiency and maximum power mid-flight. It represents a future where engines think and adjust in real time. Now, Pratt & Whitney XA101 matches that ambition, pushing complexity and performance to new levels in the race for next-generation propulsion. It shows how competition continues to drive innovation forward. Then, General Electric Catalyst brings digital design and 3D manufacturing into turboprop engines, improving efficiency while simplifying construction. It marks a new era where how engines are built matters as much as how they perform. CFM Rise looks even further ahead, reviving open fan concepts with modern technology to dramatically cut fuel consumption. It challenges conventional design and hints at a radically different future for commercial flight. Next, Pratt & Whitney Canada PW127 continues to quietly connect regions, powering aircraft that make short-distance travel practical and efficient. It reinforces that not every breakthrough needs to be dramatic to be essential. Honeywell ALF502 took an unconventional approach, using multiple smaller engines to achieve quieter operations in urban environments. It proved that smart design can solve problems that brute force cannot. Now, General Electric F110-GE-132 pushes fighter performance further, delivering more thrust than earlier designs ever anticipated. It turns already capable aircraft into something far more aggressive and responsive.